Welcome to the Explainer. So every now and then, an event happens that just completely sends shockwaves through the tech and math worlds. And we are right in the middle of one today. OpenAI just announced that an unreleased internal version of their next major model, Astra, solved a whole series of incredibly complex open mathematical problems. But listen, the real story here isn't just that an AI did some super advanced math. The actual story is that Astra fundamentally broke the human bottleneck of trust. We're talking about a massive paradigm shift that completely redefines how we verify truth, how research gets done, and honestly, what the role of a human even is in the age of advanced AI.
Here's our quick roadmap for today. We're going to cover 1. The 10-problem breakthrough, 2. The machine-checkable trust revolution, 3. The $2,000 genius, and 4. Shifting the knowledge bottleneck. Let's just dive right in because the visceral scale of this is absolutely wild.
Okay, let's start with the number 10. This is the sheer number of decade-old, entirely open math and theoretical computer science problems that Astra just totally conquered. And to be clear, we aren't talking about one lucky guess or, a slight tweak on an existing theorem. No way. Astra produced genuine, original solutions to 10 completely different problems that had utterly stumped human mathematicians for over a decade, all in a single run.
And to give you a sense of the historical weight we're dealing with, think about the number 27. That is how many years the non-sofic group question just sat there, completely unanswered. Mikhail Gromov introduced the concept of sophicity way back in 1999, and it birthed this massive central question in group theory. Do non-sofic groups actually exist? For 27 years, no mathematician could prove it or disprove it, and Astra just handed us the first ever explicit construction of a non-sofic group, completely resolving a nearly 3-decade-old mystery.
But I really want to hit you with the most mind-bending number of this whole shebang, $2,000. According to OpenAI, that was the estimated total token cost at current SOL API rates to find all 10 of these groundbreaking solutions. Not millions of dollars, not some dedicated supercomputer humming away for a year, $2,000. Keep that number in your head as we look at exactly what this model just pulled off.
All right, Section 1, the 10-problem breakthrough. To back up their claims, OpenAI didn't just drop a quick PR tweet. They released a massive 249-page manuscript collection totally packed with detailed, model-written reasoning walkthroughs for the entire world to scrutinize.
So the absolutely crucial point here is that Astra didn't just lean on one reusable trick. The problems it solves span incredibly diverse, complex extremities of mathematics. In group theory, it found that non-sofic group we just talked about. In operator algebras, it flat-out disproved Kana's rigidity conjecture, which has been around since 1980. It resolved 3 totally separate combinatorial problems from Paul Erdős's famous catalog, improved high-dimensional sphere packing bounds for the first time since 1978, and even touched quantum games and lattice cryptography. The sheer breadth of this means the AI is showing highly generalized capability across entirely different domains. It's like it speaks 10 different mathematical languages fluently.
If you want to ground the true significance of this in reality, just listen to Thomas Bloom. He's a mathematician at the University of Manchester who actually curates the Erdős Problems catalog. Now, the vital context you need to know is that Bloom is the exact same guy who very publicly dismantled a false AI math claim back in October 2025. He is a famously harsh critic. Yet, looking at Astra's output, he admits this is big news, pointing out that in terms of new mathematical constructions, this is a massive leap forward.
But okay, here is the real iceberg twist of the explainer. The math is incredible for sure, but the actual revolution, it isn't the math itself. It's the cryptographic level trust we can now have in AI logic. Welcome to Section 2, the machine-checkable trust revolution.
Look at the stark contrast between the old world of verification and this new one. Historically, if you solved a major problem, you had to rely on human peer review. It's essentially a social signal, right? It takes months, sometimes years, and depends entirely on a few highly specialized experts having the free time to read your work. Astra bypassed this entirely. Every single one of its 10 proofs shipped with a Lean 4 certificate. That means it's instant, it's binary, it's open source, and it is 100% machine-checked. Now, if you aren't familiar with Lean 4, it's essentially an interactive theorem prover and programming language with a really small, deeply trusted kernel. Instead of asking a human to read, actually, scratch that, to decode persuasive, sometimes ambiguous prose, Lean forces the math to be expressed in formal, rigorous code. It acts as this completely impartial, ruthless judge. It gives a binary verdict. The logic either compiles or it fails. You can't wave away missing steps. This totally eliminates the need for a human peer reviewer to vouch for the AI because if the code compiles, the logic is mathematically sound, period.
To put into perspective just how fast this is moving, look at the timeline. Back in May 2026, just a few months prior, an AI generated a disproof of the Erdos unit distance conjecture. Validating that single proof took 9 human experts co-signing the argument. Fast forward to this August 2026 release, 10 Astra proofs rely on exactly 0 human validators for their soundness. Since OpenAI dropped all the lean files on an open-source GitHub repo, literally anyone with a laptop can download them, run the compiler, and verify it themselves. It completely democratizes verification. You don't need a PhD anymore, you just need to know how to clone a repo.
Which brings us nicely to Section 3, the $2,000 genius. We really need to look at the unbelievable economics driving this scientific leap.
I touched on this earlier, but seriously, the total search cost to find all 10 solutions was roughly $2,000 at sole API rates. This was not some billion-dollar proprietary supercomputer locking up a data center for months. This is a highly accessible token cost that is basically the price of a decent used laptop. We have officially reached a point where producing decade-defining research costs less than a researcher's monthly rent.
And it actually gets crazier. Noah Brown, a researcher over at OpenAI, had this incredibly candid reaction to the release. He pointed out that, sure, they didn't crack any of the million-dollar Millennium Prize problems yet, but they also didn't spend a lot of compute on each problem. As he put it, it's possible to push test time compute much further. That just brilliantly highlights that we haven't even seen the ceiling of what this AI can do. If $2,000 gets you 10 decade-old problems, imagine what $2 million of test time compute is going to get you.
All right, wrapping things up with Section 4, shifting the knowledge bottleneck. Let's talk about the philosophical paradigm shift this creates for the entire tech and research industry.
So if the AI is doing the discovering and Lean 4 is doing the verifying, what on earth do humans actually do? Well, mathematicians aren't obsolete, but their core job description just got a massive rewrite. The workflow is now layered. Step 1 is discovery. Astra finds the crazy new construction. Step 2 is exposition. This is where humans actually step in, taking that discovery and writing the manuscript so other specialists can intuitively grasp it. Then step 3 is formal verification. The model formalizes the whole argument back into Lean 4. So the human's job is no longer to grind out the wrong math, it's to be the bridge of understanding.
Naturally, a shift this massive is causing some real friction in the academic community. In June 2026, over 3,000 signatories, with the backing of the International Mathematical Union, published the Leiden Declaration. The academic world is really scrambling to establish rules right now, and this declaration demands human responsibility for correctness, full disclosure of any AI tools used, and pushes back against relying on closed commercial systems. It's just a very clear indicator that while the tech is moving at warp speed, the human institutions around credit, attribution, and academic integrity are fiercely fighting to catch up and set boundaries.
So what you should really take away from all this is that humans are literally no longer the bottleneck for finding answers. Our ultimate value has completely shifted. The new human role is about choosing which problems actually matter in the first place. We're the ones defining the standards of importance, challenging base assumptions, and coordinating meaning across vastly different scientific fields. The machine is the engine of discovery, and the compiler verifies it. But the human is the navigator, deciding where the ship should even sail.
Which leaves us staring at a totally new reality for human knowledge. Think about it. We've spent our entire history valuing the people who could grind out the hardest answers. But Astra and Lean 4 just made world-class, mathematically verified answers shockingly cheap. So I'll leave you with this to chew on. When answers are cheap and verified, what questions will you ask? Thanks so much for joining me on this explainer. Keep learning, keep asking those big questions, and I'll see you next time.